Hello, everyone. Welcome to the webinar today. The topic is Introducing RisingWave Connect. This is part of our product updates that we are doing for 2025. It's a series of webinars that we will conduct. My name is Rayees Pasha. I lead the product team at RisingWave Labs. Before we go into the webinar itself, some housekeeping items. A lot of this you probably are already familiar, but just to reiterate, you're logging into this webinar, your microphone is muted, but you can ask questions through the Q&A tab at the bottom. While the presentation is going on, we'll try to answer them. Obviously, at the end of the webinar, there'll be time allocated for Q&A, but while it's on, our team will be answering questions as the webinar proceeds. This webinar is being recorded, so we'll email you the slides and also a link to the webinar later. If you have any questions or issues with Zoom, like connectivity issues, you can contact Joanna via chat. So a quick background on my bio. My background is mostly in the data infrastructure products. I've been started as an engineer working on database management systems on the optimizer side, and then I moved into product management roles, but primarily in the databases and big data space. And then and gradually, stream processing was in a sort of an adjacent space that's been coming up. So I've been with RisingWave Labs for more than 3 years now. The unique thing about RisingWave is that it's a unique product in the sense it's a streaming database. So it kind of makes it a full circle for me of how I started as a relational database engineer. Now back to the same, but through a different processing model, that stream processing, incremental processing model that we champion. Um, yeah, my education, I did a master's in computer science from University of Memphis. So I wanted to spend a few minutes to talk about this new series that we're doing, the product update series. We're calling it Rising Wave Rollout Month. So the rollout month is our longer take on launch week. We did launch week last year. We did a bunch of a series of presentations on shorter updates on product features. What we are doing now is a longer version of that, rather focusing on a specific feature. We're focusing on product functionality in a broader sense. Like for example, with Connect, we're focusing on the source and sync, how um, the new product functionality that we're adding on the user experience side enhances productivity, velocity of how fast you can build pipelines, right? In general, our goals haven't changed in terms of the engagement model, right? The idea is not so much to sell the product, but it's to engage the community on what is the latest product updates that we are building from engineering perspective, and also showcase demos wherever necessary so you can see the product in action. Um, Obviously, this is a way to interact with our community members so that you can directly see what's happening on the product side. And each session, of course, will include a Q&A at the end. You can ask any questions you have, either pertaining to the topic at hand or a future roadmap, for example, like what else is planned on this topic. Feel free to ask those questions. And then, obviously, to participate further in our webinars, meetups, we have active community. You're probably already familiar. You can go to the meetup link to subscribe to our community so that you get invitations to the future webinars. And obviously, if you are a user of RisingWave Slack is the best place to get started and get answers or interact with other members of the community. As I mentioned, this is a series. So this is the first presentation today. The topic is RisingWave Connect. We do have two more webinars planned as part of the series. The next one is on Iceberg. It's called RisingWave Open Lake. 2 weeks from now, we'll be having a webinar on that. And then we also have something called RisingWave Ultra, which is sort of a high performance edition of Rising Wave, and we'll plan to um, present on that next month. So in a way, we are making the month boundary, crossing the month boundary, but the idea is to have broad feature areas covered in as part of the presentations. All right. Um, I do want to quickly talk about a little bit about what Rising Wave is, because some of the people who may be new to our platform. So I figured a quick introduction would help just to set the table before we go into Rising Wave Connect. Um, as I mentioned, Rising Wave is um, is a hybrid product in the sense that you have the capabilities of a stream processor, but also an interface and the data model of a relational database. So in that sense, we call it a streaming database, right? It's a distributed SQL streaming database, and each of those words have specific meaning in it. Obviously, the streaming database is because we allow you to process the data and also store it as in a regular database. SQL because we are not the API is primarily SQL. It's ANSI SQL. It's PostgreSQL compatible, and then distributed because it's a distributed system. You can start with a single node, compute node, and you can go to hundreds of nodes. So in a way, it's a horizontally scalable system that you can scale out as your requirements grow, right? From an architecture perspective, Rising Wave is right in the middle of your data pipeline, right? You have upstream sources where the first party data is generated. You have your OLTP databases. You have event streams that bring data from custom sources, and you can also have some longer term data that you may have in lake houses or data lakes, warehouses. All of those are basically sources for us, and RisingWave has source connectors for each of most of them prominent data infra products, right? The data model envisions RisingWave to see each of these as unbounded streams of data that's flowing in through the system on the ingestion path, right? So for RisingWave, the stream is nothing but like a base table because our model is based on relational model, right? So in that sense, your mental model, you don't have to think of streams as something new, but just as you're dealing with tables, except that these are tables where the data is in motion, right? You can filter the data through standard SQL. You can join them as if you're joining tables. You can create indexes, views, materialize views, you can do aggregations, all the things that you perform on tables, you can do it now on streams using the same standard SQL, right? And once you process the data is available immediately because of the incremental model, right? So you only process the delta, not the entire data every time. And then you store the data, and we have a inbuilt data store called Hammock. That's our own Rising Wave data store. Very conducive for high velocity data. You have a lot of data that's coming in, and streaming workloads can be very spiky, right? So they can go up and down in terms of throughput. So this handles really well how to it handles both up and only or upstart sort of workloads, and it's ideal for low latency serving because you store the data and we guarantee freshness under 1 second, even for very bulky workloads, right? And under serving on the latency side, we can guarantee like under 50 milliseconds for even complex queries, right? So that really lends itself well for low latency serving for custom applications, dashboards, real-time alerting, or any of the things that where you really need ultra low latency as a requirement from a SLA perspective. What we also have is Iceberg native support, where you can create Iceberg tables natively, and those are managed by RisingWave all the way, like compaction, catalog management, all of the things that you need are provided out of the box. So in a way, you have a choice of how to store the data as a RisingWave table or an Iceberg table. And of course, if you don't want to retain the data, if you just want to push it to a destination, we have sync support, and there are a lot of systems that we have native connectors for, like Snowflake, Redshift, Elastic, Redis. All the most popular ones are all covered. So, so in a way, the idea is you have a unified system that does allow you to not only ingest the data, process it, store it, serve it. So you can do all end-to-end data needs through one platform. So let's switch gears a little bit to the topic on hand. RisingWave Connect. So RisingWave Connect has more to obviously um, what we are trying to address is the source and sink part, like the connection part, right? How do you ingest the data as well as how do you deliver the data? That's the part. And as I mentioned, we have connectors, built-in connectors that are there to support those that ingestion and delivery. But what we did with Rising Wave Connect is to enhance the user experience. Right? Earlier, you had to write SQL, you had to do in a way create those connectors through one-off commands that you have to run. Now all of this is through UI, which is a big change. And in a way, we're also trying. Why did we do this? In a way, we are trying to move away from what custom data integrations tools do, which is to stitch together a solution using different parts of other tool stack, right? They use Debezium, Kafka Connect, Flink CDC. All these are individually powerful products, but they require you to have knowledge on how best to use them, right? So in a way, you end up with a tool chain sprawl. You end up stitching together your own solution by using these open source solutions. With RisingWave Connect, you don't have to do that. It's a built-in streaming native, not only data integration but a transfer, a ETL's platform. In that, you can not only bring in the data real time, but you also batch load the data. If you have historical data, lots of data, you can address both those use cases. And in terms of the sync support, we have first class support for all of the major data infrastructure products. And more importantly, it's the reliability of the service, right? So since you have a single platform that does everything end to end, you don't have to worry about one subsystem not working well with another one, right? So you get everything out of the box. And then the last part is pricing and scaling, right? We do core-based pricing. We're not metered on how much data you read, how many events you read. It's based on how much compute capacity is used. So in a way, it's very cost effective, especially when you scale. If it's data infra products, yeah, unlike third party or ERP applications where the data size is much smaller, the data products generate lots and lots of data. So it's important to have a predictable pricing model so that you are not, you will start small and the pricing looks good and then afterwards, it starts to hurt, right? Let's go a little bit into the feature highlights. Now, I talked about the Rising Wave engine itself, right? It's a streaming native engine custom built for streaming. So with Rising Wave Connect, you get the same engine. There is no light version of it. You get all of the capabilities that Rising Wave platform has. All of those are available, right? So it's a low latency, high throughput. All of the things that you expect you have in the Rising Wave platform are available, right? As I mentioned about multi-destination sync support, that's a growing library. We started with a couple of dozen connectors. We keep adding more and more. And then the one-click setup. So with setting up a source, it's as easy as I'll show you in the demo now, after the slides. You connect to a source, you choose a destination, and you can get started streaming in literally minutes, right? Not even minutes, sometimes even a couple of minutes. And then the third thing is connect. We have, I know sort of lot of the data infra um, teams are moving towards adopting open data lake formats. With Rising Wave, all the Iceberg is a first class citizen in the sense of how, from a sync perspective, from managing tables perspective, all of the lifecycle management of Iceberg is baked into Rising Wave Connect, as a destination. And then in terms of a deployment choice, even though primarily built for cloud, you have, even when cloud, you can deploy RisingWave Connect on a SaaS fully hosted RisingWave Cloud cluster or BYSC cluster, or even self-deploy the on-prem offering. So you have a deployment choice where, based on your business need, you can pick what works best for you. So let's dig a little bit deeper as to why, where we see the value, right? One of the things that you see easily is the architecturally, it's very simple. You're dealing with a single product, single engine, not three, four things coming together, right? So when you typically use open source tools to build traditional pipelines, you are using them and stitching them together with separate configurations, and they all have different versions, and each time there's a version change, you have to ensure that it's compatible with other parts of the product, right? So you basically have a onerous task of ensuring that operationally there are no risks, right? So you own all that complex solution. Every component sort of introduces its own point of failure. Like where does things go wrong? Either on the scale side, performance side, maybe there is a security part that doesn't match. So you have to worry about, is the data offsets are matching? Is the schema registry in sync? Is there a problem with the connector compatibility? All of those are users' responsibilities. And if you have a large team of data engineers who know all these tools intimately, maybe it'll work. But usually that's not the case, right? And it's also a low value, low product. It's not going to help with the productivity of data engineers when they have to worry about all that instead of worrying about the data freshness or the other things that business cares, right? With RisingWave Connect, there's no separate services. You deploy the service, and everything under the hood is already matched, right? The versioning, the configuration of each of these moving parts, they're all handled for you. So you just deal with one service. You don't have to worry about multiple APIs, and there's no different control plane. You don't have to worry about going from one pane, one screen to another to manage how these systems are working. You just go through a single pane of glass to figure out how end to end how your pipeline is working, right? Just configure source, destination, everything just should work, right? And the result is you have faster setup, fewer moving parts, right? Dramatically you're lowering the operational overhead. So from that, the simplicity itself is a key value. The second is consistency of the data, right? Even if you set it up, you have to have trust in your pipelines that the consistency guarantees that you require for your analysts when they get the data, those are adhered to, right? In the case of RisingWave, we provide, because of the fact that it's not just a data integration tool, it's actually a stream processing engine that has sophisticated way of ensuring consistency guarantees. It allows those end-to-end transactional guarantees. Like we have ways to make sure that the exactly one semantics across the pipeline are followed, right? There's no risk of duplicates, no dropped events, because the checkpointing mechanism in the RisingWave platform will ensure that none of those are ever an issue for you, right? And also with a lot of the pipelines, you have an initial snapshot where you read the backfill and then you then start going to the CDC stage where you have ongoing updates. That switch from initial snapshot to CDC, it's handled gracefully. It's handled natively so that you don't have to worry about stitching together what your initial snapshot would like and what is the offset where it left off and where the new CDC updates come in, right? So in that sense, that consistency guarantee so that everything is coming together. So that's already it's handled by the system automatically, right? And then there's complex features, right? For example, if you have on Postgres, you have toast columns, which typically are used for large objects, ensuring that those are handled correctly without overhead of duplication, with no data loss. All that is baked into the product, right? Honoring the transactional boundaries so that the data as it comes is processed in the order it was received, so that it reflects the true database state of the upstream as well as the downstream, right? All of that is part of the product. So the 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 key part is that we know that the pipelines that power for your analysts are mission critical, right? So they don't have to worry about the data quality. The system, it's the goal of the system to ensure that. And then switching gears to performance, right? Some of the things is, even if you get the functional part, how do you ensure that the data is available in the time it's required? Like the high performance requirements, if you have your large amount of data, how do you fast track the backfilling part, right? If you have hundreds of gigs of data, multiple terabytes of data, that can choke a system easily. In the case of RisingWave, you have parallel backfilling. So you can, since it's a distributed system, you can spin up more compute and your backfilling phase really, kind of low, the time it takes to backfill would it can get really lowered, right? So you have those knobs that are built into the system. So you can pick and choose how fast or how slow do you want your backfilling to happen, right? And then seamlessly transitioning from backfilling to streaming. That's, you don't need a manual intervention, downtime, anything like that. Once you create the object, once the backfill is over, the CDC updates automatically flow. So it goes from a backfill phase to live streaming automatically in a seamless fashion, right? And then schema evolution, right? You have upstream sources that where there's always changes happening because schema changes happen on the application level. They flow through the upstream systems. Because the schema evolution support built into the product, it automatically does it. You don't have to worry about making sure those changes are applied or not. The system handles it automatically, right? The pipeline keeps running automatically without breaking, without you manually having to stop the cluster, adjust any configurations, and redeploying the jobs. All that is no longer needed. So basically, your pipelines adapt to your database upstream database lifecycle, not the other way around, right? And then cost. I think we address the functionality, we address the performance, but what about the cost, right? Then, like I mentioned, cost is a very key determinant in terms of, because you all, a lot of the customers may start small. They may have a couple of tables. They start small, it works great, but then they go into hundreds of tables and they start backfilling sometimes regularly every week or every quarter. So then you start seeing the bill go quite high. And with the traditional data integration tools, they use different ways, right? They typically measure based on the amount of data ingested, how many rows processed are per pipeline. So very exotic ways to price the product, right? In our case, we are not focused on um, different types of services. We are only focused on data infra tools, right? Like if you have data residing in upstream OLTP databases or data lakes, you typically have lots and lots of data. You may start small, you will grow easily very fast, right? So the pricing has to work for the larger scales as the volumes grow. So for that, what we have gone built, we have tied our pricing to the compute codes, how much capacity you have, and not on the data volume you have, right? So what that also enables you is to create a price performance trade-off so that you can pick and choose how much compute capacity do you want to use based on your SLAs, right? In a way, you could save money if you say, you know what, my freshness guarantees are not that high, so I can use less compute capacity, but I'll still get the same amount of data, right? So those sort of trade-offs are already built into the product. So in a way, you can budget, in a on a on a in a very clear way. You can look at the data and say, okay, if I go from um, 3x, 4x, 5x the data, my bill will only grow linearly or even less than that, not exponentially, right? So it's kind of a very good way to manage your budget without having to worry about like looking at like a black box of how the pricing would be, right? The cost model is very well aligned for high throughput systems in that sense. Yeah. So the next part is the observability. So we have the system functionality is there, performance is there, cost is there. But at the same time, you have to worry about how do you manage this system? How do you make sure it works? You have the visibility from end to end, not just on the freshness of the data and the pipelines, but also the back end, like how is the resource utilization? Are there any bottlenecks? If you run into, if there is issues with your pipeline, either because the data is not flowing through or if the throughput has gone down, how can you address that, right? So all of that, it's a complex mechanism, right? You're basically hooking up different systems with different amounts of throughput. So typically you need very complex monitoring tools. uh, Most common is Prometheus, Grafana stack, or you build in Kafka monitoring add-ons, things like that to actually get the metrics you need, right? With RisingWave, you get those. The deep visibility at every stage is part of the product. So you can see exactly like how the pipeline is built, the source throughput, what what are the downstream destinations for each source, what are the intermediate objects, like what tables, MVs are part of that pipeline. So all of the end-to-end user view gives you that sense of like what the lineage looks like of how the data flows through the system, right? And it's designed for both developers and operational teams. For developers, that's what they care for, right? They look at the pipeline, they want to see how does the data traverse through my pipeline. For operational teams, it's the back end, right? If I have a particular table with a certain throughput, how does that reflect in terms of amount of CPU utilization, amount of the memory utilization, amount of the storage amplification, so that they can plan accordingly in terms of troubleshooting if there's an issue or if you do need to do something. So they need a single pane of glass to look at the entire back end of it rather than going through one external dashboard to another just to make sense of things, right? So from a result perspective, you get very good, insight into troubleshooting. Even if you have any downtime, you can really quickly, figure out what's wrong with the system before you go in. All right, I see a comment. Okay, I think there's a Q&A. Okay. All right, that's the pretty much into uh, the presentation part. I want to go to the demo now. Let me stop sharing and then go back to my. Okay. So for those who are new to RisingWave Cloud, this is our portal, cloud.risingwave.com. Um, you can create an account, you can sign up and create an account. We have a free trial option where you can get a free trial account, you get a cluster, and you can create pipelines it's very easy to get started almost instantaneously. In my case, I'm already logged in. I have a cluster running. Um, so basically, once you log in, this is the interface landing page you get. And then if you go inside the project right now, the the terminology we use, we call project, which is basically a cluster that's running. So let me resume that cluster first because I had paused it. So in this cluster, it's a 4 RW cluster. It's a basic tier cluster. We have two tiers. One is called. Let me actually. I'll try to show you how to create a new cluster. So if you go to projects, if you do a create project, you'll be presented with options on how to create a cluster. We have what's called a basic fully hosted cluster, which is like a SaaS cluster. The data plane and control plane are both on in RVPC. It's a basic cluster. It's a standalone deployment. We also have what's called a pro tier cluster, where you can customize how to set up the cluster in terms of compute nodes, front end nodes, and all that. And we also have what's called BYOC, which is basically control plane is on our side while the data plane is with customer. So it's like similar to what Databricks does in their deployment, right? So in our case, in this, for the sake of demo, like I said, I already have a project, so I just resumed it. It's running. So let me go there. Um, Once you log in, you'll see on the side panel some of the areas where you can go. One is RisingWave Connect is the area, is the screen that has all the functionality in terms of creating sources, things, and that's where we're going to focus. Catalog is the page where all of the objects in the catalog will be shown. And the SQL editor is a built-in editor to run some SQL commands. It's like sort of a whiteboard functionality for us. So let me go to the RisingWave Connect. So I'm going to create a source first to my Postgres instance that's already running. So we're going to read from the Postgres and then write to Redshift, and then we also will write to Iceberg, right? First, we'll start with create the source. So let me copy over some of the so the host name is setup. Well, I'm going to the name of the database is Postgres. The username is RW pipeline. And the password. Okay. So I added all this. So I'm going to enable auto schema change. This enables us to pick up changes as changes happen upstream on my Postgres. The, the SQL source on our side will pick it up. And then just to look at other parameters. So I've enabled auto create for the publication so that the replication slot gets created automatically. I will enable parallel backfilling, but it's not needed because we are working with a very small table. But that's just an option to show you guys that it is. So I'm going to quickly try to test the connection first to make sure I can reach the upstream database. So I do see that the connection was successful. So I'm able to reach the database. So let me go ahead and select a table. I'm going to select the first table. It's called dashboard. Um, let's configure columns. So I'm going to select all the columns right now, just to keep it simple. And if you see the, if you see all the, you can also select actually if you don't wanna, if you don't want all the columns, you can pick, we can choose which one you want to select. Now, when you click generate SQL, it'll create the SQL statement that will be executed on RisingWave to create the source connector as well as the table. So here's the SQL. If you want to really review, you can see this is the SQL it generated. It's called Postgres CDC source. It has a bunch of parameters to connect to the upstream database. And then also you can see the schema of the table that we are creating. Okay. So we're going to go and execute the SQL statement. So it's right now executing it. It's created the source successfully. And it's also created the table. So both are created. Now we can go back and look at the sources. So now that'll take you to the second page is a data catalog that shows you all the sources that are there. If you go here, you already see this is the CDC source that we just created. And then the table, we create a dashboard that's also shown here. So you can see the schema of the table and what the, we can run a simple query. Let me actually, before we do that, let me share my screen to the, so let me share all the desktop so that I don't have to switch from one screen to another. So I'm gonna connect through pSQL to my Postgres instance. So let me just show you the table, the dashboard table right now. This is the schema, and let me do a select star from dashboard. So there are 16 rows. As you can tell, the table has 5 columns. So this is the table. Let's see, because and we imported the table. So it'll take a few seconds to get that table, but hopefully it's here because it already created the table, but the data, I want to make sure it's there. So if you do this, so you did see the table is already loaded. The same 16 rows are here. Now let's go ahead and create a sink. Now we want to create a sink so that we can move the data to Redshift, right? And we'll use the same dashboard table to create the sink and as well as the um, create the table in the destination, right? So here we are marking create table if not exists. Obviously, in the Redshift system, if it's not there, it'll create the table. I have dropped the table, so it's not there, so it'll create it now. And we also enable schema change so that any schema changes that happen upstream flow through RisingWave as well as all the way to Redshift. Okay. Let's specify the parameters here. So I'm gonna copy quickly. Username is man. Okay. I set the timer at 60. Actually, the schedule, this is the schedule, how, when do you want the data to be written? It is configurable. It's set to default to 120 seconds, but I'll make it really short. I'll say write immediately so that there's no delay in terms of writing. Um, so that's the configuration for the Redshift sync. So we have to enable, so one of the things we offer on Redshift is you can write directly to Redshift, or you can use S3 as intermediate staging area. We'll enable it because it'll make it faster in terms of writing to S3. So let's specify the uh, parameters for that. So the bucket for that is here. S3 region is US East 1. The path is, it's called Redshift stage. We're doing Redshift staging. I'm gonna quickly copy the access key, and then hopefully you guys don't copy this secret key while I do it. Okay. So I'm not, now I've set up the sync. I'm gonna generate the SQL to create the sync, which will, so you can see you can see the statements that'll get executed. Again, if you want to cross check and make sure everything is fine, yeah, you can do that. And then let's go ahead and execute the statements to run the sync creation. While that's happening, let me quickly check if there is anything questions here. Oh, there is some error I'm getting. Let me retry it. Yeah, this is what I feared, but well, let me see if maybe I'll try to create a Iceberg sync instead. Yeah, sometimes the downstream Redshift is not available, then that's also could be a problem. But anyway, we'll try to create a. So we're providing the warehouse path as to where the Iceberg tables, S3 tables will get created. And for catalog, we're saying we're going to use the storage catalog directly. And if the table doesn't exist, then we create it. In terms of the catalog name, it's called demo. Access key, I think secret key I had copied. Let me, it's the same, I'm using the same bucket, so I'm gonna use the same access key. Okay, and the region is US East 1. Okay, I'm going to generate the SQL now. So the SQL is generated. You can see the SQL statement. You can cross-check again to make sure that the settings are correct. And keeping my fingers crossed, let me see. Okay, something is wrong with the cluster. I could, let me run the recorded demo I had a backup just in case. I will try to do that. I'll try to run that quickly to show you how okay, let me share my screen again. Apologies. Okay, so this is the recorded demo. Um, so the part that I think where I think this is let me just back it up a little bit. So we created the source, as you can see in my recording now. We saw the source, and the editor, SQL editor was there, and then okay, schema. It's fetching the schema now, um, and and now we actually creating the sync. So from this part, I think it'll be more pertinent. So we check the table. Let me go fast forward it a little bit. Okay, we verified that okay, now we're creating the uh, Redshift sync. So we selected the table, and this is where we ran into problem, but hopefully this time in the recording you'll see that it worked. Yeah, I'm adding all of the parameters. So let me go to the part where it goes fast. Okay, now we're executing the create sync. So now the sync is created already. You can see the sync details. Um, and then now I'm actually in this part, I'm logging on to my Redshift system. And then you see that the table got created called dashboard. And I'm doing a quick select star to see the data. Does it match? The same 14 rows and 14 rows on my Postgres and Redshift are there. Now, what I'm going to do is I'm going to go and make a schema change here. So I'm going to go ahead and alter the table so that I can add a column so that you can see that the schema evolution works, right? So I'm adding a column called new call int, and then I'm adding, yeah, just to verify that the new column is added. And then I'm going to a add some rows. So now so it'll take some time for the data to come. Now I'm adding 2 rows to this thing. Now, if you see the dashboard, you will see that the table, yeah, it's still not showing the new column. Now, if you go back and if it, now this time will be, let me quickly check. It'll check again. If you check the tables, you'll see the new column here. Not yet. I think it probably took a little bit longer. Let me move forward. Okay. Okay, now you see the new column got added. You can see it on the screen. And if you go check do a select star, you will see the new rows. The 16 rows. You see it not only adopted the new column, but also showed the extra rows, right? Now, does it show up on the Redshift side? That's what we're going to check now. And then I'll stop the demo. I'll stop the recording. So now we are logging on to this, and you see the 16 rows. So the rows, the schema, the new column got added, as well as the 2 rows got um, this thing. So that's the end of the recording. Okay, sorry about that. It's always a challenge to um, with the live demos. So uh, I think we have about 15 minutes. So why don't we take questions? And before that, let me just quickly recap, right? Debezium or Kafka stack, on each of these dimensions, like time to first table, change implementation, doing rebuilds or backfills, operational overhead. On all of those, there are clear advantages that we have with RisingWave Connect, right? So I welcome you to try and give us feedback, and let's take some questions. Okay, first question I see is will the Connect product be available as a self-hosted or just from the cloud? So initially it's going to be from cloud. That's how we always roll out our products because we have a lot more control over in terms of feature functionality. But there is a new library we're building that will have comparable functionality in terms of all of the automation like schema evolution, automatic creation of objects, all of the things that you have it in RisingWave Connect will be available on self-hosted too. Okay, I'm gonna read through the chat here. What Iceberg meta stores do you support? So we support, obviously the storage meta store, JDBC, on AWS Glue. We support Polaris, any of the REST API meta stores, all of those are supported. All right. Any other questions? Okay. All right. Do you support Iceberg REST, AWS SIG for Iceberg REST? We do support. I can confirm that. I'll have to check SIGV for Glue that I'm not familiar. I'll get back to you, Steve. Thank you for that question. You talked about Grafana and not needing it. Okay. The question from Anthony is, you talked about Grafana and not needing it. Do you support Hotel? Yeah. So we do a lot. We have log forwarding capability, so you can set up your own infrastructure if you wish to go deeper into metrics and logs beyond what our cloud product offers. You can go, and because we do have a very extensive OTel support, so we can give you some guidelines on that. All right. I see some couple more questions. Which clouds or cross-cloud deployments do you support? Question from Peter. We are available on all three major clouds, AWS, Azure, and GCP. Cross-cloud deployments, they are usually single cloud deployments. So I'm not sure what you mean by that. Like, is it that the client is on one cloud while the RisingWave service is hosted on one? That's possible, but um, the challenge might be the cost because you have the data that has to ingestion costs, and especially from one cloud vendor to another, could be cost prohibitive. But in terms of the capability, there's no restriction as such. Okay. Let's see. Any other questions? Will your Iceberg functionality, are you positioning RisingWave as a full analytics lake that can replace Snowflake, Databricks, ClickHouse? That's a very broad question. Our goal with Iceberg functionality is that we are a streaming first architecture, right? We are on the right path. So any data that has to flow through to your data lakehouse has to go through some sort of transformation. So if you're setting up a bronze, silver, gold sort of a medallion architecture or one of those sort of architectural patterns, we are the cog in between that allows you to not only ingest the data but do some transformations before you store the golden copy, right? So from that perspective, we see ourselves as an ingestion, storage, and transformation platform, but not so much as a querying platform, right? You could still use the tool of your choice for querying. Could be ClickHouse, could be Trino, whatever engine it is. So I think our positioning for how we see Iceberg, I think if you attend our next webinar, you'll probably get a lot more. I can go into more detail, but as I said, it's mostly on the table management aspect. Is there any free to use version of Connect? Uh, so this, yeah, I mean, there is a free trial available. And then the on-prem version, when we release, it'll be open source version. So you could download and you can try on your own. But that's not out yet. But for now, best is to get a free trial account on RisingWave Cloud, and that's probably the best way to go about it. Okay, I see a question. Backup DR protection by being deployed across clouds. You answered about the cost component, but still wondering about the consistency guarantee. Okay, the follow-up to the question about cross cloud, I think Peter is asking, how do we ensure the consistency guarantees? So the consistency guarantees we provide are on the source and sink. So um, in terms of the processing, out of order processing, uh, the consistency guarantees on the utmost at once, like at least once, those are the things that we ensure, right? But once it reaches the destination, if actually, if even if it is another cloud, it shouldn't matter because the same guarantees will carry through. Um, any date for on-prem? For date for on-prem. So I think we already have an early version available. So if you reach out to us, Hore, we're happy to send you some details. But that functionality is not as broad as the cloud version. It has Postgres, it has Iceberg, it has Mongo, some of the subset of the functionality of what is on the cloud. So you can definitely try it now. Okay. From Anthony, is this a correct summary? RisingWave Connect brings a friendly UI to what could be done through SQL. Are there new features that? Okay, so that's a good way to summarize. Yes, largely it's correct. There are some features that you cannot do through SQL, right? Some of them are exclusively available through RW Connect. You could, since the source code is all open source, you could build it on your own, but yeah, there are some features, for example, RW Connect uses, those are on the cloud side exclusively, and that cloud service side, they are not available in the open source. So in a way, the answer is largely yes, but there may be some exceptions. I hope I answered your question, Anthony. Um, let's see. Any other questions? All right. So I think we have 5 minutes left. Thank you all for joining the webinar. I hope you found it. Okay, in the demo, okay, there's one more question just as well. In the demo, the number of sources linked looked limited compared to the SQL version. Is there a roadmap to enable other sources? Good question. Yeah. So yeah, I mean the wizards screen that you saw, it'll be a growing list, right? So right now we have about a couple of dozen connectors on all. We will be adding more and more as the time passes, right? So we'll bring parity basically to whatever is there on the SQL version, like the self version versus the UI. Um, our plan is to bring everything there eventually. All right. Okay. Um, I think last call. Any other questions? Okay. If not, thank you everyone. Glad to see and hope to see you again on our next webinar.